is a good word problem to figure out how to apply trigonometry to a practical situation. So we have a blimp that is in the air at a height of 500 feet, and that's going to become important. And it lies directly over a line from Soldier Field to Adler Planetarium on Lake Michigan. So this is in Chicago. So it's right directly over this particular line that I'm drawing right in here in red. The angle of depression from the blimp to the stadium is 32 degrees. And they've kindly marked that right in there for us. And from the blimp to the planetarium is 23 degrees. So those are the two angles that we're dealing with. And they want to know, well, if that's the case, how far is it from Soldier Field to the planetarium? So this is a case of find the triangle. And I think we can see the triangles right here. I have one triangle right there. That's 500 feet. Here's a base, and here's a hypotenuse. And then I have another triangle, the same 500 feet. Here's the base. Here's the hypotenuse. Now, the thing you have to remember in this particular problem is a little bit of your geometry, whereas I have parallel lines, and if they are cut by a transversal, then what angles are going to be the same? Well, this angle here is going to be the same as that angle there. It's going to be the same as that angle there. It's going to be the same as that angle there. So this 23-degree angle is the same right over here. That is also a 23-degree angle. And this 32-degree angle is the same as this angle that I just drew right there. So I can now, what I want to find is I'd like to find, well, what is the length of this side here? Let's call this base sub 1. And the length, that goes to here. And the length of this piece here, we'll call that base sub 2. And then when I add base sub 1 and base sub 2, I'm going to get the total distance. So, how do we calculate those? Well, I have a, let's start with this one. Let's start with this one right here. And I'm going to get the calculator out. So I have a 32-degree angle, and I have, I can do tangent, because I have opposite over adjacent. So tangent of 32 degrees is equal to 500 divided by base sub 1. Well, I can do that. That's the same thing as saying base sub 1 is equal to 500 divided by tangent 32 degrees. So let's go to the calculator. I say 500 divided by tangent 32, and I find out, well, that's 800.17 feet. Let's just round it to 800 feet. That's 800 feet. And let's see, can we do the same thing over here with this angle? Well, we have a 23-degree angle right there. And I can do, again, I can do opposite over adjacent. So tangent 23 degrees is equal to 500 divided by b sub 2. So b sub 2 is equal to 500 divided by tangent 23 degrees. Well, 500 divided by tangent 23 degrees. That is, so b sub 2, that's not, that shouldn't be a plus, it should be an equals. B sub 2 is equal to, let's call this 1178. Well, 1178 plus 800, I get a total distance 1,978 feet. So this problem, like many of the others, it's a problem of finding the triangle, but in this case here, we had to like think of like two triangles and put two triangles together. Not an uncommon thing to have to do. Good problem.